Hello, grade 3 students. Today we're going to have a new subtopic of force. So here on page 135, so please get your textbook and join me in studying this lesson. So here the subtopic is what can we use to measure forces? So is there any material that we can measure force? Last time, we learned about 5 effects of forces. So this time, we're going to measure if we will be able to measure force. So here, by looking at the picture, so we have here sea waves and a feather. So the force of these waves is very big compared to the force needed to lift this feather is very small. So obviously, we have a big, very big force in this example of a wave or sea waves. But here, there is a small, very small amount of force to lift this feather. So is there any way to measure the size of force? Okay, so here we're going to learn that there is a tool to measure force and we called it force meter. So later I will show you what is a force meter and we're going to have some demonstration on it. Is that clear? Okay, so one way to measure the size of a force is to use a force meter. So I have here a force meter. It's look different to the example of the book. But here I get it from our school in the science laboratory. So if you have this tool at home, you can use it and it's good to try it for yourself. Okay, but if you don't have this at home, it's okay. No need to buy. Okay, so later I will show the demonstration how to use this. Okay, and as we can see, I hope you can see it in the video, there are some numbers. Okay, so those numbers will indicate how much force we have used to lift or to carry something. Okay, so here forces are measured in the unit Newton. So the symbol for Newton is big capital N. So the unit is named after the famous scientist Sir Isaac Newton. So Isaac Newton is a famous scientist and who have um, invented the 3 laws of motion. You will learn more about him and his theories when you are in higher level. So here in the picture, if we're going to look at it on page 135, this is the force meter and then it carry or it lift a mug. So a force meter is used to measure the pulling force of this mug. So what is the size of the pulling force? So we can see that it touches the measurement tree. So the unit of the pulling force of this mug is 3, 3 Newton. So we're going to read it as 3 Newton. Is that clear? So later I will show a different material for this. Okay, so next page, page 136. So here we have another example of picture. So we can use a force meter to measure the force needed to make a block start moving. So this is a wooden block. What will happen to the reading on the force meter if we place something heavy on the block? So here, um, we can see here the measurement for the pulling force for this block is, we can see here, let's read it. So here's 0, 0 0.5, 1, 1.5, 2, and then we have 2.5 and then 3. So here the force is 3 Newton, but when we put another thing on it, so here on the second picture we can see we have a rock. So a heavy rock is placed on the block. So a pulling force is then applied to make the block start moving. So now, how much force do we have here now? So let's read it again. So the numbers are very too small here. So we have 0, 0 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and then now we have 4, 4 Newton. A while ago in the first picture, we have 3 Newton. But when we put uh, a rock on it, the Newton become 4. So it means we need uh, more force to pull this thing because it become more heavier. So here, let's move on to the next one. Try this. Use a force meter to pull things around you. Measure the force needed to make them start moving. So we have here a drawer of a cabinet. So when we pull this, according to the picture, the force that we have here is 3 Newton also. Okay. So if you have this kind of tool at home, you can try it. So how much force do we need to pull this drawer? So this is the last part of this subtopic. So what we have learned here. First, force meter can be used to measure forces. Okay. So what do we call to this tool? We call it force meter. Is that clear? Next, second, forces are measured in the unit Newton or big capital N. So Newton is the unit for force. And we know that we get that name from a famous scientist, Isaac Newton. So exercise. This instrument is used to measure forces. So here we have a beanbag. When we pull the beanbag using the force meter, we will answer the following questions. What is the name of the instrument? So we called it a force meter. So what is the pulling force of the beanbag? So here we can see that the pulling force of this beanbag or the force that we have here is 2.5 Newton. Is that clear? Okay, second. Henry and Gita took turns using a force meter to pull their shoes across the floor. They wanted to find out whose shoe needed a larger force to make it start moving. And then these are the results. For Henry's shoe, okay, they need 6 Newton, okay, to pull his shoes. For Gita's shoes, they need 4 Newton to pull her shoe. So let's answer now the following question. Whose shoe needed a larger force to make it start moving? Is it Henry's or Gita's shoe? So obviously, the larger force that we need to make the object move or to start it to move is Henry's shoe. Next, why should the children carry out the experiment on the same floor? Why do they need to do it on the same floor? So, to make the test become fair, to have a fair test. Next, letter C, Gita placed some glass marbles inside her shoe. Will the force needed to make her shoe start moving increase or decrease? So what do you think? If we put a marble or we put marbles inside the shoe, do you think what will be the force pulling? It will be increase or decrease? So obviously, if we put something more on the thing, like the example that we have on a block with rock, the pulling force increases. So the answer here is increase. So that's it. That is the end of our subtopic lesson for today. So let's try to use this tool in different things. Okay, so let's try to use this material now. So, but first, let's look at the labels here. We can read here Newton. So, the range here is from 0 to 10. So, here 0 Newton. This one 0 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, and then 8, 8.5, 9, 9.5, and 10. Okay, so the first material that I'm going to use to check how much pulling force do we need is my slipper, this one. Okay, so we're going to hook it here. Okay, and then let's check if how much force do we need. Okay, so let's check. So it reads as more than 0.5. So to be exact, it is 0.6. Okay, so the next thing that we're going to test or to measure the force is a stuffed toy. Okay. Okay, so when we lift now the stuffed toy there, okay, let's read the Forcemeter now. So here it touches to 3.5 Newton. So the force that we need to lift this toy is 3.5 Newton. Okay, so next,
Okay, so the next item that we're going to test is my shoes. Let's see how much force do we need to pull this. Okay, so when we pull it, we can see that we just use a 1 Newton to pull this thing. So it means uh, my shoes is very light. Okay.
Okay, so now you're going to answer your activity book. So to answer this, you really need to have a force meter. But I told you, if you don't have like this, no need to buy outside, okay? Because we need to stay at home. So I'm just going to uh, demonstrate this and use it to our activity, and whatever result that I get here, just copy it and then write it on your activity book. So again, later, once we use this in different objects again, just copy the result and write it on your activity book. And then the rest, the questions, you should answer it by your own. Is that clear? So here, this is the instruction. First, tie a string around a book. Attach a force meter to the string as shown in the step 2. Use the force meter to pull the book. Then after that, take the reading on the force meter when the book starts to move. Then record your reading in the table on the next page. Repeat steps 2 and 3 to obtain a second reading. Record your second reading in the table. So let's look at now page 80. So please get your activity book so that you can follow each step. Okay, so here number 6, it says here carry out steps 1 to 5 using a box. This one is a brick in your book, but I changed it into a box because I don't have brick. So later I will use box, a pencil box. So next, a drawer, a door, and a chair. So we're going to put all the readings here. Then after that, to answer this on your own, list number 8 until 9. Is that clear?
Okay, so the first thing that we're going to pull is a book. So this is my book. I already tied it with a rubber band because I don't have any string. So let's now check how much force do we need to pull this. Okay, so by pulling it, let's check now the force meter. So here we have 2 Newton. So the pulling force for this book is 2 Newton. Okay, so we're going to do now the second reading. Let's check if it's still the same or it will be a different result. So once I pull this, let's check how much force do we have here. Here we have 2.5 now. Okay, so a while ago it's 2. Now for the second reading is 2.5. So put it in your activity book. Okay. Okay, so second item is a box, a pencil box. So here, this time we're going to pull it up. Okay. So when I pull it up, the Newton is 2. The pulling force that we need is 2. So again, let's do it for the second reading. Going to pull it up again. And then the result is 2 Newton. So please put it in your activity book. Okay, so the third object that we're going to test is a drawer. So I attach the hook on the handle and I'm going to pull it now. So here we can read it as 8 Newton. Okay, so let's do it on the second time. For the second, here we have 7.5. Okay, so 7.5. So the fourth object is a door. So I'm going to attach this here so that I can pull it properly. And then I'm going to pull now the door. So here we only need 1.5 force or 1.5 Newton to pull the door. So again, for the second time, here still the same, 1.5 Newton. Is that clear? So the last item is chair. So I'm going to attach it again here. Then I'm going to pull the chair. So to pull the chair, we need 5.5 Newton. Okay, so let's do it for the second time. So here the reading is 6 Newton. Okay, 6 Newton.
Okay, so that's it. So please put all the results here, and then after that, send to me your answers by taking a photo of your activity book page 80. Is that clear? And the next meeting, we're going to have our last subtopic, and you're going to do a activity again, the activity book. Is that clear? That's all. Bye.